Domain-driven design can be quite a challenging topic if you're starting out. So in this video, I'm just going to give a brief summary of the common terminology, and hopefully this makes the learning easier going forward. On a high level, you could think of the terms as maybe serving two purposes. There's usually a client or a business analyst or somebody who's requesting a system or a code to be created. Some of the terms are more relevant for the client or the business analyst, and some other terms would be more relevant once we start doing lower level coding or developing the solution. So the first term is a domain, which is simply the problem or the system being built. So for example, a social tennis app where, for example, you might want to find mates against which to play over the weekend, or a cleaning service, a classifieds for advertising cleaning services. So each of these are specific problems or specific business requirements that need to be coded maybe with specific terms. Then we've got abundant context. Once we have a domain, this starts becoming a decomposing the problem into actual deliverable or manageable units. So this could be delegated to a specific team or a specific business unit. Example of abundant context would be if we have a cleaning service again, which is the domain, we might have a public facing website, also a mobile app. So this would be for just the advertising section or the part that does the classifieds. Another abundant context would be the backend, where advertisers or service providers go and place their adverts. So they might need some kind of content management system or ad management system. Also, billing might be another abundant context. Reporting could be another one. The point of abundant context is that it's usually quite a lot of work that needs to be done, or different subsystems might need a whole team or a whole different technology stack altogether. So these could be grouped together into abundant context. Next up is ubiquitous language. It's common terminology that is specific to the business domain, and this common knowledge has to be reflected throughout the system. So the developer mustn't go in terms or name things in whichever way they feel like it. But ubiquitous language means that the business analyst, the whole team, basically the business analyst, the client, and the developers have all agreed on how to name core parts of the system. Entities and value objects. This is mostly where the business logic lives. It's only purely just business logic, which doesn't usually talk to any other item, a database, or make any other external API calls. Entities usually map to a table in a database, and value objects are usually just reusable classes or reusable objects. For example, a payment rate. A service is there's more business logic. An example would be if we are billing the client, there might have been a number of cleaners that would have done the work. We might have a class and it simply records the number of hours worked. Next up is a repository. Repository is actually a common design pattern that does with wrapping everything to do with saving to a database or reading from a data store. You don't have to use a repository pattern. You could use other patterns, but the point being that data to do with data access has got to be in one place. Aggregates, if you've got a number of objects that only make sense if they have a parent, for example, a cleaner. A cleaner might have a schedule, remuneration rate, and a rating assigned to that cleaner. So it wouldn't make sense for a rating to live on its own or a schedule to live on its own as an object. Everything or all the interactions of the system have got to go through these cleaner objects. A factory simply means that creation of objects that might be a little bit more complex. Again, the cleaner example. To instantiate a new cleaner object, you might need to create blank remuneration or rating that are blank or schedule. The functionality to create this cleaner needs to also be in one place. Domain events are just simply communication across the system. So for example, if cleaner has started working, an event would get raised and this information would get sent to the rest of the system. So that is the terminology in as brief as possible, and I hope all of this was helpful.